Ever get that feeling of like pure awe when you see a massive thunderstorm? That raw energy, the incredible power of nature.
Oh, absolutely.
Well, get ready to have your mind blown because we're diving into a phenomenon that's even more electrifying than we thought. Radioactive thunderstorms.
Yeah, we're talking about storms that pack a punch way beyond just rain and lightning.
We're talking about gamma rays, the highest energy form of light in the universe. And get this, they're surprisingly common in thunderstorms. Way more than scientists ever realized.
It's true. Recent research using, and this is cool, modified U-2 spy planes.
Spy planes. Okay, I'm already hooked.
Yeah, they're showing that most, maybe even all, large tropical thunderstorms are emitting these gamma rays, and they do it throughout their entire lifespan. They're like giant, naturally occurring particle accelerators up in the sky.
Okay, hold on. So we're not just talking about like a few stray gamma rays here and there. These storms are constantly buzzing with this intense energy.
Exactly. Think of it like a pot simmering on a stove, right on the verge of boiling over. That's kind of the constant state of these thunderstorms when it comes to gamma ray emissions. But then on top of that, you also get these incredibly intense bursts of gamma radiation, and these are often linked to lightning.
So it's like there's this whole other level of activity happening within a thunderstorm that we've like never even known about.
Exactly. And the research has even uncovered two like entirely new types of gamma ray bursts that happen within these thunderstorms. One of them is incredibly short-lived. I mean, we're talking less than a millisecond.
Wow. And the other? What's got scientists so excited about the other type?
This one's called a flickering gamma ray flash, or FGF for short.
Catch you.
It's a rapid-fire burst of about 10 gamma rays, and this all happens in just a tenth of a second. Picture a strobe light. But instead of light, it's this incredibly intense energy.
Wow, that's quite an image. So how does this FGF, this flickering gamma ray flash, how does that connect to what we already know about thunderstorms, like lightning?
That's the really interesting part. Scientists think that these FGFs might actually be the missing link in understanding how lightning itself forms. It's like catching a glimpse of the very beginning of that electric spark right at the moment it ignites.
That's incredible. But how does a thunderstorm, even a massive one, how does it generate something as powerful as gamma radiation? I mean, we're talking about the kind of energy usually seen in like extreme cosmic events, right?
It is mind-blowing. But there's a really fascinating explanation, and it all starts with those insanely strong electric fields that you find within a thunderstorm. Imagine, if you will, 100 million ALA batteries, all stacked end to end.
Okay, that's a lot of batteries, even for someone who loves their gadgets as much as I do.
That's the kind of power we're dealing with here. That's the power of a thunderstorm's electric field, and it's strong enough to accelerate electrons, those tiny particles that, whiz around atoms, to almost the speed of light.
So we've got these tiny particles zipping around with unimaginable energy. How do the gamma rays come in?
So picture this. You've got these super speedy electrons, right?
Right, like a bajillion tiny lightning bolts.
Kind of. They're propelled by the thunderstorm's massive electric field, and they end up smashing into air molecules. And when that happens, it's like a chain reaction. Each collision knocks loose even more high-energy electrons.
So the energy just keeps growing inside the storm.
Yeah, exactly, like a snowball effect. And eventually, it hits a point where it's so intense that it triggers, get this, nuclear reactions.
Hold on. I thought we were talking about thunderstorms, not, atomic bombs.
Right. It's wild. But those reactions, that's where the gamma rays come from. And get this, they even produce these tiny, tiny amounts of antimatter.
Okay, now you're just messing with me. Antimatter.
Nope. It's true. It sounds like something straight out of Star Trek, but it's real. It just goes to show how unbelievably extreme the conditions inside a thunderstorm can be.
So these storms are like mini Big Bangs happening above our heads.
In a way, it's more like they're natural particle accelerators just churning away up in the sky.
Mind-blowing. So we've got these powerful gamma rays, even traces of antimatter being produced in thunderstorms all the time. I mean, this changes how we think about everyday weather, doesn't it? What's the big takeaway for those of us down here on the ground?
It does change things. For one, we need to rethink how we model atmospheric radiation. I mean, these thunderstorms are happening all over the planet, way more than we thought.
Right.
And if they're pumping out gamma rays more than we ever imagined, well, that affects how much radiation is up there in the atmosphere.
Makes sense. Any other implications from this research? What about lightning itself?
Oh, absolutely. Think about it. Scientists have been trying to fully figure out how lightning is generated for decades.
It's true. It's still kind of a mystery.
Right. And this discovery, this whole flickering gamma ray thing, it could be a huge piece of that puzzle.
So this isn't just about understanding thunderstorms. It's about understanding lightning itself.
Exactly. It's like we got this brand new window into how these incredibly powerful forces of nature actually work. It could even lead to better lightning prediction, which would be huge for safety.
Wow, imagine that. Knowing exactly when and where lightning would strike.
Yeah. It could revolutionize things.
If something is, I don't know, normal as a thunderstorm can be this complex and have these mind-blowing things going on inside it, what else are we missing? What else haven't we noticed?
You know, that's what I was thinking. It's amazing how much we still don't know about our own planet.
It really makes you think.
This kind of discovery just highlights the incredible power and complexity of the natural world. Makes you wonder what else is out there waiting to be discovered.
That's what makes science so cool, isn't it? That constant sense of wonder and discovery. It's like we've always known thunderstorms, right? But now we're seeing them in this whole new light, or I guess gamma ray vision.
Exactly. It's like someone handed us a pair of those X-ray specs you see in comic books. We're getting a glimpse of this hidden world of energy, these reactions we never even imagined were happening right over our heads.
So just to recap for everyone,
Yeah.
those lightning bolts we see during a storm, they're just the tip of the iceberg.
Right, like way more is going on.
Underneath all the drama, there's this constant churn of gamma rays, even a little bit of antimatter. It really changes how we think about the air around us.
It really does. It's a whole new perspective on something we thought we knew, like, since forever. A good reminder that the natural world is full of surprises.
And this is only the beginning, isn't it? This research opens up so many new avenues to explore.
Oh, absolutely. The possibilities are incredible. Like, maybe we could use this new understanding of thunderstorms to study climate patterns, or even, like, the air we breathe.
Wow, that's amazing.
It could even change how we predict severe weather. Maybe even lead to new technologies we haven't even thought of yet.
So next time we're caught in a downpour, or watching lightning, remember, there's a whole lot more happening up there than we realize. It's like a secret world of energy and particles playing out on this massive scale.
It really is a wild world out there. It makes you appreciate the power of nature and the science that helps us understand it all.
Absolutely. Well, on that note, we'll wrap up this electrifying deep dive. Join us next time as we explore another fascinating corner of our universe.